In Python, it's pretty simple. For example, we can have the variable a, and then we set a value of 3 to it. Now in Python, variables are case sensitive, so these two are not the same. A and uppercase A, they're different. We can print variables by using the print statement, a, or then print a. Okay, and then Alt-Enter, because we're in Google Colab, to run the block. Now, there's different ways we can specify variable names. The best way is just to use the alphabets. For example, I can write my whole name, 3. I can even write Ahmed loves Python. Basically, however long you want to make it, the alphabets are fine. You can even add numbers to it. So 1, 2, 3 equals 3. But what you can't do, for example, this will run. But what you can't do is you can't start with numbers. This will give an error. And I believe you cannot start with special characters either. So this will also give an error. Now in Python, you actually can't declare variables either. So for example, in other languages where, for example, you can do, and I think in C++ you could do like int val, like something like this would be valid. By doing this, you'd create a variable that was an integer object. But in Python, you cannot do that. Whenever you define a variable, you have to assign it to an object, a value. There's a reason for this, and it goes down to what is happening under the hood. Now, in most languages, the variable is itself the object, no matter what form it is. But in Python, that's actually not the case. In Python, variables are just references or labels that point to particular memory locations. Objects are what are stored in that memory location. And everything in Python is an object. Integer, float, whatever you name it. They're all objects and they all have their own memory locations. And variable names just point to those memory locations. To demonstrate what I'm trying to explain, let's say we create a variable a and assign a value of 3 to it. What do you think will happen if you reassign a value of 4? Will it be the same variable? Well, the way we can do this is we can do print and then we can use id to check the memory address. So let's do a, and then let's do print id, and then a again. Now let's run this. Clearly you can see that there are different addresses. And the reason for this is because what is happening is 3 is given, is an object, is an integer object, which is given its own memory location. But then 4 is a new integer object created at a new memory location. The variable a was pointing to this memory spot, but now it's pointing to this memory spot. Now speaking of assignment, we can even assign multiple variables at once. So we can say a, b, c, d, e equals 1, 2, 3, 4, 5. This is valid. The simplest type in Python is what we call a null type. And the way we write it is like this, x equals none. So this is the null type. We can print it, and then we can also check what type it is by doing print type x, and we get none, and it is class none type. Strings can be made using single quotes, double quotes, and for multi-line we can even do triple quotes. So like this, we can say Ahmed loves Python, and we can print, for example, printing the single quotes, print just that name in single line, but printing, it will print the multi-line as is. A raw string will look like this. So we can do name raw, and then we write an R, and then we write our string. But what is the difference between a raw string and a normal string? Well, the difference is a raw string ignores escape characters, while a normal string does not ignore an escape character. Well, what is an escape character? An escape character is a special type of character put into a string such that it can perform added functionality onto the string. For example, the \n, let's say we were to put it in here, what that does is it adds a new line. It is a type of escape characters. There are more escape characters in Python. So to demonstrate this, let's create two different strings. One is raw and one isn't. So we can write raw string \n, then my last name, Salim. And then same thing, but it's not raw. So we can write. Now if we print the first one, name raw, it'll also print the escape character as is because raw strings ignore escape characters, but if you print name, now it didn't ignore the escape character, it actually implemented it. So now we have a new line. Raw strings are especially useful for file paths. For example, this is a file path in my computer in the C drive. If I didn't use the raw string, there could be a chance that a backslash could be interpreted as some sort of escape character. But if you do raw string, then we don't have to do extra work. We don't have to write like double backslash. We can just use single, and then this should work. So Python has many number types, but we'll just go over a couple of them. You could have integer. You could have a positive integer, x equals 3. Or we could have a negative integer, y equals negative 3. And then we can verify that these are indeed integers. Cool. We can also have floats. We can pretty much do the same thing, but then all we do is add a decimal. We have float. And last but not least, we can do complex. For example, you have a real component, 4. Then you have an imaginary component. For the imaginary component, you write the component, 3, and then you just put a j next to it. No asterisk, no other character in between, just j right next to it. Okay? To write booleans in Python, we have to have the uppercase letter for true, and the same lowercase letter for false. These are both bools. So we see class bool and class bool. If you use bool and we use 1, this becomes true, but a bool of 0 becomes false. Containers are quite literally what the word says. They're objects that hold other items or other objects. There are many types. Let's start out with list. A list, the way you write it is you use square brackets. And let's say we want to have the integers from 1 to 5. So we write 1, 2, 3, 4, 5. Okay? Now a list, what it actually is an order container of items. Now the keyword here is order because order is important. For example, this is not the same. If you were to swap the 4 and 3. And the way that we can verify that is we can use double equal to check if the value of two objects is the same. So, and it prints false. So again, order matters. Similarly, we have tuples. Tuples are actually quite like literals. So if you do 1, 2, 3, 4, 5, and then we were to write the same thing and swap the order of 4 and 3, and then print out, again, false. But in both these examples, if we were to unswap and run both of them, we get true because order matters. Now, if these are both operating the same, then what is the difference? Well, the difference is that lists are what you call a mutable object because it can be changed, but a tuple is what you call an immutable object because it can't be changed. To demonstrate that a list can be changed, the list actually has methods to allow it to change. So let's go over some of those methods. For example, if you had a list from 1 to 4, you could add a value of 5 to the end of the list by doing append. Let's print the list. Okay. We can change value by index. So let's say, now, indexes in Python start from 0. So this is index of 0, index of 1, 2, and 3. So let's say we wanted to change the value at an index of 2. So we would write L square brackets 2 equals 3. Then we print it. And we see that it has changed. Next, we can remove an object by index. So let's say we want to remove the 1, but it is at an index of 0. So we do 0. It is gone. But we can also remove by value. So this is by index. Now let's do by value. So we want to remove the value of 5. So let's do L.remove. And we have removed 5. Cool. With a tuple, it won't work because the tuple does not have those methods. For example, let's say if I were to change this to a tuple, so we got attribute error, tuple object has no attribute append. Try this. Tuple object does not support item assignment, so we can't, because we can't change the items. We can't remove by index, and we can't remove by value. So like I said, tuple, you cannot change it. Now since lists and tuples are ordered containers, we can actually get their values by index. How can we do this? For example, let's say we have the same containers, one as a list and one as a tuple, both from 1 to 10. Already you saw how you could index it. For example, you want to index the list at the position of 0. Simple, right? But let's say we want to get the final value. Well, Python has a hack for that. We do t square brackets and we use a -1. So this will get the value at the end. Okay? Another way you can actually do, you can even do this. For example, to get the size of the list, we can do length print. It is a size of 10. And what we can do now is keep in mind that indexes start at 0, so this must end at 9. But the size is 10, so we can say print t length of t minus 1, so 1 less. And again, we get the final value, same thing. So these are basically two different ways to get the final value. Now if you were to use print t -3, what do you think would happen? You'll get 8, because we're going 3 back. Let's try that. Indeed, we get 8. Now just as an index gets you a value by position, you can actually get a slice of values by specifying an interval from position to position. So for example, let's say you want to get the slice of 1 to 4. We can do it like this. So let me take these out. We can do print t square brackets. So we start at position 0. Now you want to follow along here. We do semicolon and 0, 1, 2, 3. Do we write 3? No, we actually write 4. So this is a little funky on Python's part, but I guess this is something, it's just Python's way of doing it. So I guess just live with it, where the final value in the slice has to be 1 greater than what the final value you actually want. So we get our slice. Similarly, if you want to get the slice from 5 to the final, how could we do that? We could do t5 is at an index of 4. Cool. And then we can do the length of t. Why not t minus 1? Because remember, I just said that the final value is +1 of what you actually want. Run that, we get what we want. 5 to the final of 10. You can even get a slice by increments. For example, let's say we want to get 1 to 7, but at a step of 2. We could do this. We could write 0 to 8, and then another semicolon, then specify our step size, which is 2. And voila, we get that. What about 1 to 10, but then step of 3? Well, we can do print t 0 to length of t, then step of 3. And there you go. But what is a faster way of doing the exact same thing? You can just do this. Print semicolon, semicolon, and then just do 3. When you do it like this, just double semicolons, that assumes that you want to do the whole list, and then you just specify your step size. Similarly, we could have just even done a step size of 2. I hope you're starting to get the picture. And if you just want the list by yourself, remember I said a complete semicolon is just a list, so just get the whole list. Sorry, you get the whole tuple. And then even if you do double semicolon, let's see what you get. Get the whole tuple. You get the idea. And whatever I did for tuple is same for list and vice versa. The indexing, the slicing is the same. Now just as lists and tuples were ordered container, a set is an unordered container. So for example, if you write, this is how you write a set, use curly braces. Let's say we have a set of 1, 2, 3, 4, 5, the integers. If I were to write y equals 1, 3, 2, 4, 5, we swap the 2 and 3. What do you think would happen? So let's try that. Press x equals, print x equals y. It's true because in set order doesn't matter. these two are assumed the same. Similarly, if you did unswapped it, also the same. Order doesn't matter. Now, another feature of sets is you can also not have duplicates because a set is a container for items that are supposed to be unique in a sense. So for example, if I were to write 4, 4, and then 5, and 5, if I run this, we get true because these have duplicates. As a matter of fact, if you go ahead and print X, this is what you will see. You won't even see the duplicates. And now since sets do not have order, they cannot be indexed. So for example, this will throw an error. Now just as lists are mutable, so are sets. So set also has its own methods to update it, to change it however you want to change it. So let's go over some of those methods. For example, we can use the add method to add a value to the set. So we're adding 6. Why did I use S? Sorry, I meant to use X. See, now we added a value of 6. That's the add method. We can use clear if you wanted to empty the set completely. So now the set is empty. And then we can even use discard. So for example, let's go ahead and take this, put it over here. And let's say we wanted to take out 2. Now we have the set but without 2. Now sets are in fact very powerful when you want to perform operations on objects that are supposed to have set-like features. For example, let's say you have 2 sets, we use our Venn diagram, and let's say you wanted to take the union of them, the intersection of them, tell whether they're disjoint or not disjoint, whether one is a subset of the other or one is a superset. These are all operations you can do in Python on sets. So let's go over some of them. For example, if you had 2 sets, correct? Now these 2 sets, if you were to take the union of it, you can do this. And similarly, you could also do this. It doesn't matter. And right away, we get the whole Venn diagram. But the overlap was at 3, 4, 5, so we didn't include a duplicate 3, 4, 5. Okay? And similarly, we can even get the intersection. So for example, we can do replace union with intersection. And you run it, we get 3, 4, 5. Okay? We can even check whether they're disjoint or not. For example, if you have these 2 sets, clearly these are disjoint because they have no numbers in common. And we can check that by doing print S1 is disjoint. And similarly, vice versa. And you get true because they're both disjoint. But as a counterexample, these are not disjoint because they both share a value of 4. So now we get false. We can even check if one set contains the other, or if one set is contained in the other by using is superset or is subset respectively. So for example, we have these 2 sets, S1, and S1 contains S2 because 2, 3, 4 are inside S1. So we can check that it is a superset by writing print S1 is superset S2. And then we can check if S2 is a subset by is subset S1. And if we run this, we get true and true because S1 is a superset of S2. It contains S2. So contains, I know this can be a little confusing, that's why I'm specifying here. Contains S2. And S2 is a subset of S1 because S2 is contained in S1. So notice the distinction. Now sets can be changed, they're immutable. But what if you wanted to not change them? And what if you want to force that quality that you didn't want them changed? Well, you can use frozen sets. And all you do is write it like this. Frozen set, parentheses, and you input a tuple. So 1, 2, 3, 4. Now if you print type fs, we get frozen set. Now if you try using the same methods to change the set, it will no longer work because you can't change it. So for example, if you try using F6, you will get an error. Now by now, all the containers that we have worked with, we've been constructing them pretty manually. We've been punching the numbers in directly. Obviously, if your container gets very large, this is very inefficient. So what are some hacks that we can create containers quickly? Well, one such is a range, and it looks like this. So we can do range. Let's say we want to create a list of all the integers from 0 to 100. Use a range by doing range 101, and then we can convert it to a list. Print list using list r. And if we run it, we get 0 all the way to 100. And again, it seems like a common theme in Python. I don't know why. Where whatever you want to go up to, you have to specify one greater than that. And this is if you want to just specify by stop. So this is by stop. But what if you want to specify a start and a stop? So you can do r equals range. Let's say you want to start at 50 and then end at 100. We do this. So this is by start and stop. So now print. Now I'm going to make it into a tuple. Tuple of r. Run it. So now it starts from 50 and it goes to 100. Last but not least, so we did by stop, we did by start and stop. Just like for slices, how we included increments, we can also do the same for range. So r equals range 50 to 100, but you want to do increments of 5. So now it's by start, stop, and steps. So now I'll actually do a set. And as you can see, right now they're unorganized because it is a set. Order doesn't matter, but you can see that they were generated as steps of 5. So all the previous containers were just containers of single items. A dictionary is actually a key value structure, where basically each item is a key value pair. So to demonstrate this, let's write a dictionary. So D equals, and use curly braces. Now our first key value pair will be key of A, semicolon 1. Second key value pair is B, semicolon 2. Then the third one, C, a value of 3. Okay? So print type of D, it is a dictionary. Now dictionaries are also mutable. They can be changed. So you can update a dictionary. Let's say you wanted to add 2 more keys. We could do it like this. So D, the update method. And we have updated our dictionary. Cool? We can even change a value of a dictionary by key, and we can do that by subscripting. So let's say we want to change at index of B, and we want to change it to 20. So we can do this. And clearly we changed it to 20. And you can even delete a key value pair by using the del command. So delete, then just specify the index. Let's say you want to delete that B. So now, if you print it, we have deleted that key value pair, B20. Now remember earlier I said that in Python you cannot declare a variable, you can only initialize it. Well, what is like one workaround to declare? You can initialize it to an empty. So for all the different container types, this is how you would initialize to an empty. For example, for list, you could do L and then empty square brackets, or you could do L equals list. So let's do L2 equals list. Both these cases you get empty. So you get print L2. Now you can check the size of a container by using the length method. So you do print length L. So they're both empty and they're both 0. Similarly for tuple, we can write T equals empty parentheses, and T2 equals tuple empty. Then let's check it. T2, then we check the size again. T, the length, T1. Oh my bad. This is supposed to be a T2. So empty, empty, 0. So for sets and dictionary, I'm gonna go ahead and just copy and paste it. This is how you would write it. Now you wanna pay attention to one thing clearly. In sets, remember I said sets you create by using curly braces, but you also create dictionaries by curly braces. But the funny thing is, For empty dictionaries versus empty sets, the curly braces are only reserved for the dictionary. So in each case, if you run this, we see you get the set, frozen set, and these are empty dictionaries. You can actually even print these to verify that these are dictionaries. And like I said, you can use the length function to check the size of any container. So for example, for all our containers that we covered, this is how it will look like. List, tuple, set, frozen set, dictionary, and we check each, and we get the sizes. 5 items, 4, 6, 7, and then 3 key value pairs.